Okay, so I think it would be better to repeat a little bit from the previous session because we started a fresh lesson that's called Algebraic Identities. So I think, because we are recording it and the students will have the opportunity to see the videos later on. So let me just start from the previous session, but not to make the session very boring for you. I will add something to it, of course, to be able to have some questions to publish problems of the week tonight. Okay, so I think it's good. A starting point is if I start solving some of those problems of the week number 7. Okay, so so before doing that, let me just write the first algebraic identity that you actually already know. Let me write the formula here for you. So you know that a plus b to the 2 is a squared plus 2ab plus b squared, yes? So when we can use this identity whenever we have a binomial and we want to square it, yes? So this rule tells us that you can square the first one plus 2 times the first one times the second one and plus the second one to the power of 2. It's very important to be able to express math formulas in your own language, for example, here English, yes? So I don't just look at it as a formula. So this tells me that when I want to square the sum of 2 terms, this is the rule. I can square the first one, I multiply 2 by the first one, multiply by the second one, and then the second one to the power of 2, yes? So if you don't mind, let us go directly to problem number A. So I know that this is super simple for you by now, but let us have the opportunity to solve it. Okay, so we want to, part 1 of the problem A, this is the question. Use the quadratic rule. This is called the quadratic rule, to expand the following expressions. Yes? So the first one, let me write it a little bit lower. So 2a to the 2, b to the 3, minus 3a to the 3, b to the 2, and then raise it to power 2. Okay, do you think that I can use this pattern to expand this? Yes? Yes, because I have 2 terms added or subtracted, and I want to raise it to power 2, so I can use that rule. Yes? So the rule tells me that you need to square the first one, which is 2a squared b cubed to the power of 2. And then plus 2 times the first one. The first one is 2a squared b cubed multiplied by the second one. The second one includes a negative sign itself, so it becomes minus 3a cubed b squared. And then finally plus the second one to the power of 2, yes? Okay, and then hopefully you know what to do. What's the answer to the first bit? By the way, is this a quadratic rule, this one itself? Is it? So be careful, yes? It is being recorded. Yes. Yeah. So is it a quadratic pattern or not? No, it's not, because even though I have 2 terms, but they are not added, they are multiplied. So I cannot use that rule, yes? So I'm raising it to power 2 by the rule that I can raise each one of them to the power of 2 individually. So the first one becomes 4, the next one becomes a 4b6, and then you have numbers here. 2 times minus 3 is minus 12, and then you have a squared and a cubed. You can combine them. What's the answer? What's the answer?
A to the 5.
A to the 5, yes, and then b to the 5 again, because b cubed and b squared have the same thing, but the next one is positive or negative?
Positive.
Positive, yes, it is 9a a to the 6 b to the 4, yes? So that is expansion of this expression by the quadratic rule. Of course, you can write this expression and multiply it, but the whole goal of this lesson is that you have to use the quadratic rules, and I want to teach you algebraic identities, so I want you to learn how to use them effectively, yes? Okay, so there is another question, number 2. So let me call, this was number 1, problem A, part 1, and problem A, part 2. So what do you think about this situation? I have x squared minus 2x plus 3 to the 2, yes? Okay, can I use immediately this pattern for expanding this expression? The immediate answer is not really immediately, because you see that how many terms are involved in this expansion? 3, yes? But this quadratic rule only tells you how to expand the sum of 2 terms. But the sum of 3 terms can be regarded as the sum of 2 terms, yes? If I know to take these 2 things, for example, the same thing, yes? The one object. So I can write it like this. So this is, I can write it as x squared minus 2x. I regard this as one object or one term, and then I have plus 3 and then to the power of 2. Yes, is that clear? But now how many terms are involved? 2 terms, yes? One term is the whole combination and the second term is 3. So this is the first term and this is the second one. Yes? So I can use this pattern again. So the pattern tells me that you need to square the first one. So they square the first one, what happens? It becomes x squared minus 2x to the 2. And then plus 2 times the first one times the second one plus the second one to the power of 2. Is that understandable for everyone? Yes? Okay. But then what happens, this becomes another quadratic rule on its own, because it's x squared minus 2x, so I have the difference of 2 terms squared. So that's exactly a quadratic pattern. So I can use the quadratic pattern once more. So what happens? The first one to the 2 is x4. 2 times the first one times the second one. What's the answer? What's the answer? Minus 4x what?
3.
x3, x cubed, and then the last one to the power of 2 is 4x to the power of 2, yes? And here I have 2 multiplied by 3, which gives me 6, and then I multiply 6 inside, yeah? So it becomes what? 6x squared minus 12x, and then finally I have 9, yes? But usually, of course that's okay, but usually if you can simplify, you have to simplify, yes? Can I simplify more? Yes, so I can just write it, and usually it is better to write them in a descending order of exponents. So I would write x to the power of 4 first. I write minus 4x cubed, and then this one and this one will give me 10x to the power of 2, and then minus 12x plus 9. So that is the final expansion, yes?
In the faucet, it's actually not joined together.
Yeah, I actually corrected that, you were right. Yeah, but that was my answer in the faucet. Yes, that was correct, but I would prefer to write it in that way. Yes. There was also one misprint in the challenging problem. I corrected this today, but anyway, I will talk about that later. Okay, but one mistake might be this. Can I assume this in this form? Can I take this one expression and write this because there is no guarantee that, so I chose these 2 to combine together and I left 3 alone. But there is no reason that you want to do that. You might want to have x squared alone and you want to combine 2 other terms to make them one term. Is this the correct way of writing then?
No.
No, why not?
3 should be negative.
Yes, 3 should be negative. So if you do that, this is wrong, because when I multiply this negative sign inside, it becomes negative 2x, negative 3, which is not exactly this expression, yes? So you can do that. Of course, you need to remember that you have to write this minus here. And now, if you continue this solution, then it becomes the first one to the power of 2 minus 2 times the first one times the second one, and then you have plus the second one to the power of 2. Yes? This is correct again. And if I calculate that, it becomes x to the 4. And then I multiply it, it becomes minus 4x cubed minus 6x squared. And then this is another quadratic pattern, so it becomes 4x to the 2 minus 12x plus 9. Did I make any mistake? Yes. Can you detect the mistake? Yes?
It shouldn't be minus 6x squared.
It should be what?
Positive.
Positive, yes, because I multiplied negative 2x squared inside, so it becomes negative. The next one becomes positive. Okay, but let me just simplify this again. So this becomes 10x squared, and then I have minus 12x plus 9. Is that right? Yes, and you see that the result is the same as before. So you have this freedom, whatever you want to do, but do it properly. Is that clear? Okay, so I will skip the next one, not to make it so boring for you. Then we learned a little bit about another identity, which is also very important. So let me write the names here. So this is called quadratic rule. And then we learned a little bit about conjugate rule, yes? So what was conjugate rule? I really want you to memorize them at the end. After understanding them, you should memorize them. So what was the rule? Anyone else? Yeah, say something, yes?
In parentheses, a minus b times a plus b equals a squared minus b squared.
Yes, exactly. So that's a conjugate pattern. So when it is helpful, when I have two terms, once subtracted, once added, and I want to multiply them. So you need to have this in your memory. It's a very ubiquitous, actually, expression in mathematics. So a minus b multiplied by a plus b is always the a to the power of 2, always and always negative sign, and b is squared, yes? So that's the conjugate pattern. So I don't want to, because this is very trivial, so I don't want to waste your time, but I want to give you one question. This is question number E, part 1, yes? You are supposed to expand this expression. Yes, so 2a plus b plus 3c and then plus 2d. Okay. Because very simple questions you have already seen in Math 1C, so let us skip them. But you might say that, okay, this is very restricting. I need to have exactly two expressions subtracted and the same two expressions added. Okay, so why this is so useful that I have to memorize that? No, the answer is that, for example, in this case, you can also use this identity, but you need to be a little bit observant and more smart, okay? So you need to discover the conjugate pattern in this product. If you can do that, of course, you can do it much simpler. Now, can you help me to discover the pattern?
You can put b plus 3c minus 2d in parentheses.
So let me, I didn't hear you. Which ones?
B plus 3c minus 2d, and then 2a plus b, and then 3c plus 2d.
Do you agree with him? So he is saying like this. Let me repeat what he is saying. So you are saying that I write it in this form or what? Are you saying that I can take these three together and these three together? Are you saying like that?
Yes.
But I don't think that's quite right. Yes? Yes, Simon, you want to participate?
Yeah, 2a plus 3c in one bracket
Yes.
minus parenthesis b plus 2d.
Yes, that's the good pattern. Why this pattern is not correct? Because you are just caring about this minus sign here and this positive sign, yes? So what happens for this one which is negative? Do you understand what I mean?
Yeah.
So this is not a conjugate pattern in that form. So the conjugate pattern that actually Sima mentioned actually is very correct. So I would also prefer that one. I don't think that we can discover more type of patterns here. If I'm wrong, just tell me, because that was my impression as well. So I would write it like this. So 2a and 3c are exactly repeating themselves in the second brackets with the same signs. Yes? So this is a good candidate for my first term. So I would look at this problem in this way. So 2a plus 3c, I put them in brackets here. And then I have the same 2a plus 3c there. So let me put them in another bracket here. Yes? Okay. This is easier. Let me first do this one. I have b and 2d left alone. Yes? So let me write them together. Okay? So I have one term added to another term. And this term is repeating itself exactly here. But what I need the minus of that term. Yes? Do I have the minus of that term here? Yes. But you need to do what? There is a negative sign here, a negative sign here. I pull the negative sign out. Then what is left from here is b. What is left from here is 2d. And then I close the brackets. I'm not saying that this is very easy. If the number of terms are more than this, I might myself get confused. But I want you to learn what is the idea behind that. First of all, I want you to appreciate this equality is true. Do you agree with this one? Yes? Why? Because you see this one and this one is exactly the same. If I multiply the minus sign, it becomes minus b minus 2d. That's exactly the same. And these two, everything is the same. So this equality is a true equality. But why this is useful? Because I can immediately see that the conjugate pattern emerges. Yes? I have one expression minus another expression, the same two expressions added. And I want to multiply them. So I really do not need to multiply them one by one. Okay, now can you tell me yourself, Simo, what would be the answer then? Not the final answer. What's the intermediate answer? So from here I should write what?
2a plus 3c squared minus b plus.
Yeah, so you mean this? You mean this?
Yes.
Okay, that's right. Yes, do you agree with him? Yes, Simo, do you agree? Okay. And then is it finished or not? Is the problem finished? No, because expansion means continue until you do not have any brackets involved anymore. Yes? So it's not finished. But do you see any new pattern emerges now? Yes, Emil? Yeah, this quadratic rule. How many of them? One here, one there. Yes, so I have two quadratic rules. So what can I write? I can use now my quadratic rule. So that's a combined problem. You need to know both rules to be able to solve this problem. So this one, the first one to the 2 is 4a squared. 2 times the first one times the second one. 4 times 3 is 12. a times c is ac. The second one to the 2 is 9c squared. But I have seen students sometimes mess this negative sign. So you need to be careful. I put this negative sign on open brackets, okay, and then answer this and then apply the negative sign in all the terms, not just the first one. So it's crucial, okay? So the first one to the 2 is b squared. 2 times the first one times the second one is 4bd, and then finally 4d squared. Is it finished? Still not, because still I have brackets left, so I have to remove that last bracket. So what happens? It's 4a squared plus 12ac plus 9c squared minus b squared. What should I write here? Minus, that's very important, minus bd and minus 4d squared. Can I simplify more? No. I don't see any similar terms involved. Yeah, so that's the end of the problem. Is that clear? Okay, so that was a very crash review of what we have done in the previous session. But the pinnacle of that session was we learned something new. Yes, do you remember? That was a little bit more exciting. So you see this quadratic pattern I can deform it into a new form that is useful for some other kind of calculations. Yes? So what do I mean by that? So I have a plus b to the 2 is equal to a squared plus 2ab plus b squared. Yes? What can I do? I want to move this term to the left-hand side. So then what happens? I have a plus b to the 2, and then I move this one to the left-hand side. You know that it should become negative 2ab. And then what is left on the right-hand side is a squared and b squared. Yes? So this is what is left. So if you don't mind, let me write it in this form here. Okay, and by the way, as I told you before, this is not a soulless formula, yes? This is talking to you. What is it talking? It tells you that if you are interested in the sum of two squares, a squared plus b squared, you can write a plus b to the 2, but if you stop here, that is wrong, unless you continue and write minus 2ab. So let me emphasize again that a squared plus, I have seen mistakes, something like this in the exams a lot. So remember, this is not correct. So that's the correct formula. A squared plus b squared is a plus b to the 2, but if you stop here, that's not complete. You have to continue with negative 2ab. Yes? So that's not a new formula. That's exactly the quadratic pattern. But in this form, you can use it to solve a great range of problems. Okay? So this is why I want to go to problem F. Okay? And I want you to participate in this solution. So let x and b be real numbers. Yes? So in mathematical language, x and v belong to the set of real numbers. Yes? X and y are real numbers. And we know two pieces of information about them. We know that the sum of these two numbers is equal to the product of the same two numbers, and it is equal to negative 2. We know that. Yes, we know. Now, the question is, calculate x to the 2 plus y to the 2. Calculate x to the 4 plus y to the 4. Calculate x to the 3, y to the 3. And finally, calculate x to the 5 plus y to the 5. And you can, of course, continue this list. So this is a very important problem in mathematics. If you know the sum of two numbers, if you know the product of the same two numbers, you can immediately answer the sum of squares, the sum of the fourth powers, the sum of the cubes, the sum of the fifth powers, and etc. You can continue this list, of course. Okay, so let us get some experience. From the previous experience, I think you can immediately answer that. How can I answer this first question mark? Yes?
You can just replace that formula with the
Yes. So this formula is valid. By the way, that's a good idea to write this. Whatever is inside the box to the 2 plus whatever inside this circle, I don't know what is inside, to the 2 is equal to the box plus the circle to the 2 minus 2 what is inside the box multiplied what is inside the circle. That's another way of seeing the same formula. So if I want to solve x squared plus y squared, I myself choose the box to be x, choose the circle to be y. And then it produces a formula. This will always produce formulas that is correct. But that is your responsibility, that the formula produced is useful for the problem in the context. Yes? So that is your responsibility, and that's the fun part of mathematics. Yes? Okay, and that is not very hard, by the way, to guess. So I want to have x squared plus y squared. I ask myself, what is the best choice for square and what is the best choice for y to be able to use the formula to solve this? It's very immediate, yes? X should be chosen for box, y should be chosen for circle. So then I would have this formula. So this becomes x to the 2. Okay, help me to write that. What should I write in front?
X
Yes, please, loud and clear. Yes, minus 2xy. Yes, that's the formula. And what can I continue? How should I continue? X plus y is directly given in my problem. It's minus 2. So I would write minus 2 to the 2. Minus 2 times. Xy is also given to be the same number. It's minus 2. So it becomes minus 2. And then this becomes positive 4. It becomes positive 4. And then it becomes 8. So the answer to this is simple 8. Yes? Is that clear? But I want to now calculate x to the 4 plus y to the 4. Now, what is a good choice for choosing, what is a good choice for the box and the circle? Yes?
We choose the box to be x squared and the circle to be y squared.
Yes, so that's a good choice. Yes, yes. Because if I put x squared in the box, there is another 2 on top of that, it becomes x to the 4. And x to the 4 is actually what I really need. So that's a good choice. So for the second problem, I can replace the box with x squared. I can replace the circle with y squared, yes, in the same formula. So then I put it here. So it becomes x to the 2. This is my box, to the 2, plus y to the 2 to the 2. Yes? And this is equal to x to the 2 plus y to the 2 minus 2x squared y squared. Is that understandable for everyone? Because this box is x squared, this circle is y squared, so 2 times box times circle becomes 2x squared y squared. Okay, but now how can I continue? This is exactly what I need. X to the 2 to the 2 becomes x to the 4. This is a better name for that. And then I have y to the 4 is equal to. Okay, so I have this situation. You need to help me. Okay? What can I put inside the first brackets? Yes, y, we can just calculate it right now. So it is this part of the problem is not independent of the first one. For example, if you get this question in the exam and you haven't been asked to calculate this, you have been asked only to calculate this, you yourself need to understand that I have to calculate the sum of the squares first and then use it to calculate the sum of the fourth root. But this is, I'm just guiding you. So exactly, so I put 8 here. So you see this 8 will find a way here. Okay. But x squared y squared is not given directly in the problem, but that's not an obstacle, is it? So what can I do for that? Yes?
Write xy squared.
To the 2, yes? Because x squared, y squared, by the rules of powers that we learned before, it's xy to the 2, agree? So, okay, so I can write this one. I can write it as xy to the 2. But xy is given directly in the problem, that's also minus 2. So this becomes minus 2 to the 2, yes? And then 8 to the 2 is 64. And then minus 2 to the power of 2 is positive 4. Multiplied by that is negative 8. And finally, you get 56. So you get 56. Is that clear? Okay, now this is done. This is also done. This is a little bit more tricky. Of course, you have some experience of that from the previous week, but you see that there is no suitable choices for box and circle so that this produces this one directly, yes? So what should I do? Do you remember something?
You make an equation system with x plus y and x squared plus y squared.
No, it's not system, because if you say system of equation, it means that I want to find x and y using those pieces of information. This is not what you mean, yes? The system is not working. By the way, that's a good question. Why I didn't solve the system? So I could simply, you might think why Babak is actually doing these weird things, because the simplest thing, for example, because we want to learn mathematics, so let me ask you some question. if I give you this question, if I tell you that x plus y is equal to, for example, say 2, and I give you x minus y equals to, say, 4. I give you this, and I ask you the same question. And I ask you calculate x squared plus y squared. I ask you calculate x to the 4 plus y to the 4, etc., etc. Okay? What is an alternative way to solve the problem? Probably the most natural strategy to solve the problem.
Addition method.
You mean solving the system, yes? So I solve the system and I find x and y. Solving the system is very simple in that case. I add them, y is eliminated, x and x becomes 2x, and 2 and 4 becomes 6, and then x becomes 3, yes? So this is my x. I put it back here. I immediately find that y is minus 1. Do you agree with me? And then I can answer them very simple. So the first question mark is x is 3, so it becomes 3 to the 2 plus minus 1 to the 2, so it becomes 10. I can also answer this immediately, yes. It becomes 81 plus 1 is 82. And I can answer any sort of questions here. Why do you think I am changing my strategy? It's important because this is mathematics. Mathematics is not just some the cut and dried rules that I just tell you that you obey me, yes? This is not something like, I don't know. So, okay, forget about that. Okay, so you need to understand what is going on. Why I am changing my strategy even though this problem looks very similar. I can do this. I can write x plus y equals to 2. Is it 2? No, it's minus 2. And then I can write xy equals to minus 2. And try to find x and y as I did before. And when I found them, then I don't need to do these fancy things. I can just plug those numbers there and find the answer. Okay? So why do you think I have to change my strategy? Yes, please?
We don't have enough information to solve this.
No, in principle we have. How many unknowns we have in this system? 2. How many pieces of information I have? 2. Usually, if that's the case, the number of data that I have matches the number of unknowns. In principle, I should be able to solve it. And by the way, it's not that hard to solve this problem. Here, you answered x to the 2 plus y to the 2 without knowing x and y individually. Do you understand? But let me try to find x and y individually. Okay, give me a hint. How should I proceed?
Substitution method.
Yes, exactly. So we have to use substitution or elimination method. That is the core strategy in solving any kind of systems of equations. So these are not just names, they are strategies. You need to remember them. Because how many unknowns I have? I have 2 unknowns. I cannot solve 2 unknowns simultaneously with one equation. So the first thing that comes to my mind, can I eliminate one of these variables in terms of the other and put it into the other equation? And this can happen immediately, yes? For example, I can calculate y from here. It becomes minus 2 minus x. Do you agree? And then I put this y here. Then what happens? It becomes x. Instead of y, I put minus 2 minus x. It's equal to minus 2. Yes? And then let me multiply things inside. So it becomes minus 2x minus x squared is minus 2. What type of equation is this? Quadratic equation. So I move everything to the right, for example. X squared plus 2x negative 2 is equal to 0. Do you agree? And then I solve this and I find x. When I found x, I put it here and I find y, and then I put everything back into these question marks and solve them. But let me see, this is really, really worthy. Then you would appreciate this method over that method. Okay, so let us try to do that. Let us try to do that. Okay, we want to solve this equation. So let me write from here. X squared plus 2x minus 2 equals to 0. Okay, so what is the, you know the ABC formula. So x is minus b plus and minus square root of delta is b squared minus 4ac divided by 2a. So if I continue, this becomes minus 2 plus and minus square root of, this is 4 minus 4 times this times that is 8, and then divided by 2. So then it becomes minus 2 plus and minus square root of 12 divided by 2. And then what can I do? Instead of a square root of 12, I can write 4 times 3. Square root of 4 is 2, so I can take it out. So it becomes, I want to simplify. So this becomes this divided by. Do you understand this bit?
Yeah.
Yes? Because 12, square root of 12 is a square root of 4 times 3. But the square root of 4 is 2, and the square root of 3 is just a square root of 3. Why I did this? Because I can factor 2 out. Then it is minus 1 plus and minus a square root of 3, and I divide it by 2. Then this 2 is cancelled. And you see that I have 2 values for x. I need to take care of both of them. Oh, sorry, this is still x. Yes? And when I calculated this x, I have to put it here to find y. Yes? So let us concentrate on one of the solutions first. So what is my y? Y is equal to minus 2 minus 1 plus square root of 3. Are you following? So I calculated the x. I got 2 answers. For the time being, I am just concentrating on one of them. I took that one and put it here. I found my y. This is my y, agree? But I can simplify. Multiply this negative sign inside. So this becomes minus 2 plus 1 minus the square root of 3. And then it becomes minus 1 minus the square root of 3. So, okay, what are my values for x and y? It is minus 1 plus the square root of 3. And it is minus 1 minus the square root of 3. So you see, first of all, I more or less suffered a little bit to find the appropriate x and y. But the main problem starts from now. Can you see that? So these are your golden numbers, by the way. You should be able to convince yourself that the sum of these two numbers, what is the sum of these two numbers, by the way? Yes? It's minus 2, yes? And if you multiply them, what's the multiplication of these two numbers? Do you see a pattern there? I want to multiply these two numbers. What the pattern is? Yes? Conjugate pattern, yes? So let us check that we have done everything correctly. Yes? So x times y, it's minus 1 plus square root of 3 minus 1 minus square root of 3. Can you detect the conjugate pattern? Yes. This, the number and these numbers added, subtracted, multiplied. So that's the conjugate pattern. So what's the answer? The first one to the 2, which is? 1. Minus the second one to the 2, which is? 3. And what's the answer? Negative 2. So xy is negative 2. Yes? So we have done it correctly. But we suffered, actually. Now the real suffer starts from here. That's actually torture. Yes? So you need to calculate x squared plus y squared. Okay? Yeah, fairly easy. But then x to the 4, y to the 4. X to the 4 is a quadratic pattern on its own. We have 2 terms to the power of 2, so it gives you 16 terms. Yes? Another 16 terms coming from here. So it becomes 32 terms. It's doable. I really want you to do it at home if you want to learn mathematics, okay? Not what with 4, but with 2. By the way, let us do 2 here, okay? It's exciting, isn't it? You need to enjoy, otherwise it doesn't work. So, x to the 2, y to the 2, let me calculate it. What do you expect to get immediately?
Minus 2.
No. What do you expect to get? 8, yes? We are supposed to get 8 back. Let us check our chances, yes? So x squared plus y squared. Okay, so if we cannot calculate this to 8, my reputation is gone in front of that movie, yes? So let us do something together. So x squared plus y squared. So x squared is this one, and this is y squared. So let us implement these things here. So it's minus 1 plus square root of 3 to the 2 plus minus 1 minus the square root of 3 to the 2. Okay, now help me work it out.
Conjugate.
No? A quadratic. How many?
Okay,
How many? 2 of them. One of them here, the other one there. Yes? So I raise it to power 2. So let us do it in our head. The first one to the power of 2 is 1. Yes? 2 times the first one times the second one. The second one to the power of 2. 3. Yes? Here, the first one to the power of 2. 2 times the first one times the second one. What's that?
2 squared.
Positive, negative.
Positive.
Positive, because both of them are negative. The second one to the power of 2 is 3. Do you see 8?
yes.
Yes, good. This is gone. 1 plus 3 plus 1 plus 3 is 8. Which one do you prefer now? This innocent way or that way? By the way, that way is not fully solved
There's another.
because there is another sum. But the point is that they always comes in pairs. So it doesn't matter. You see, the value for y is the second value for x. So you really don't need to do it. But now assume that you want to follow exactly the same strategy for x to the 4 and plus y to the 4. You have to suffer much more, yes? At least you have 16 terms for the first one, 16 terms for the second one. Here I have only 3 terms for the first one, 3 terms. It was manageable. 16 terms is also manageable, but it's boring, isn't it? So this is a very effective way of calculating that. So in principle, if you have learned your math lessons before, you didn't need this smart way. You should still be able to calculate it as I did here. Okay? But now I think you see why it's better to change the strategy. You feel it with your flesh and bones, yes? It's clear that I have to change my strategy, otherwise I will be disintegrated after solving so many problems. But we can solve all of them more or less immediately. We calculated x4 to the 4 more or less relatively simple. And then now let us go to x cubed plus y cubed. What do you think we can do here? Let me guide you somehow. Do you think that this formula is directly useful? Is it directly useful for the third case?
It's hard to convert 3 into the...
There is only one way. If you want to use this formula to solve this one, what is the only appropriate choice for box?
3 divided by 2.
Yes. So I need to replace box with x to the 3 to divided by 2, yes? Because then, after raising the box to the 2, it gives me x3. But this is useless, you see. I don't have any information regarding this special case in my calculation. So if I insist to use this formula to this, I cannot solve it. So this is why you need to be creative and be smart. And of course, experienced. Yes, Natalie, do you want to say something?
Can't you use 3 plus y to the power of 3 minus 3x to...
Yes, you can use that, but I haven't taught that yet. Yes, this is why I don't want you to use that. Exactly. That is that innocent formula that you always have on the top of your formula sheet, but nobody cares about it. Yes, I don't know why it's there, okay? But anyway, I will teach about that later because I want to talk about algebraic identities a lot, okay? So, but now exactly using the things that we have right now.
You could use x squared plus y squared multiplied by
Exactly.
x plus y.
Yes, that's the strategy. So what I do, x to the 3 plus y to the 3, if you remember, I told you this. I found x plus y is directly given in the problem to me. I myself found x to the 4 and y to the 4 and x to the 2 plus y to the 2. So let me write my information here. X to the 2 plus y to the 2 is what? 8. Okay, you have some ideas that if x is multiplied by x squared, it gives you x cubed. And the same thing happens for y. But of course, mathematics is a real unforgivable theory, science. It will not forgive you. You need to follow the precise rules, yes? So, who wanted to answer? Yes, Luve told me what to do. I'm just following him, yes? So, he said that we multiply these things together. 1 minute, yeah. So, I have to multiply them. What happens? It becomes x plus y times x squared plus y squared is minus 2 times 8. First of all, I want to make sure that you really understand this. Do you understand that? It is clear. If I have two numbers a and b which are equal, if I have another pair of numbers which are also equal, do you see that if I multiply a and c and if I multiply b and d, what is the relation between these two numbers then? Yes? It's clear that they are equal. So I am using this fact. It's a mathematical argument. So if two numbers are the same, it's clear that if I multiply these two, the results would be the same. So I am using this fact here. But here I don't have any problem with this part. This is already minus 16. But can I just write x cubed plus y cubed here? No. Because I want it. It doesn't actually gives me the permission to just do something wrong. I have to follow exact rules. Okay. X times x2 is x3. X times y squared is xy squared. And then yx squared. And then y cubed is equal to minus 16. Okay. And now, what is my question mark? I have the piece that I needed. I have some extra pieces that I don't need them. Yes? So what should I do? It motivates you that probably it's a good idea to write these two expressions next together because I want them. And I can do what here between these two? Yes, Martin?
Replacement minus 2.
Not yet. Not yet.
Factorize.
Yes, you have to pull this out. Yes? So what can I pull out? It is xy, and then I have x plus y. Is that understandable? x3 is x3, y3 is y3. But instead of these two terms, I have written this. Do you agree with me? Let us check that. Why this is correct? Because I multiply it back. xy times x will give me this term. xy times y will give me this term. So this is a valid way of doing things. But now, more or less, you understand what's going on. Problem is solved, yes? Because this is given to me in the beginning. It's minus 2. This is what? Minus 2. And this is what? My question mark. So the question mark, minus 2 times minus 2 is 4, is equal to minus 16. I am looking for question mark. Is it simple? So question mark is minus 16 minus 4. So what is the question mark finally? It's minus 20. Yes? Is that clear? And so you see this problem is not that hard. Of course, it is more tedious than the previous one, but it is much simpler if you want to tackle the problem directly by finding x and y. So we have a little bit of time, 1 minute. So let me finish this one. X to the 5 plus 5 to the y to the 5. So what's the answer? How should I simply calculate this one? Now you have some experience. Yes, this was a hard trick. This is why. The difference between me and you is probably I try to remember the tricks. If you remember, this is mathematics. You cannot solve the problem all the way from scratch every time. You need to have something in your memory somewhere, okay? So, okay, if I want to solve x5 plus y5, because I know that you really understand very good at the spot, but you forget. You need to overcome with this forgetness somehow. Then you will glorify actually in your studies. It's really, really important. Okay, so what can I do with x5 plus y5? I want you to introduce one of you one method, the other one the other method, okay? So, you first.
I guess you put in brackets x squared plus y squared times x cubed plus y cubed.
Okay, so you are trying to make x5 plus y5 by a combination of 2 and 3. Yes? So let us do that. So x to the 2, oh, I erased that. I hope that, yeah. What was x to the 2 plus y to the 2? It was 8. And then x to the 3, we calculated just right now. What is that? Minus 20. I multiply them with the same strategy. I multiply these two numbers, and I multiply this is minus 160. Yes? And then I start multiplying. So what happens? This becomes x5 plus x2 y cubed plus x cubed y squared plus y to the 5 is minus 160. And then the same strategy. You see x5 plus y5 is my question mark. I can put them next to each other. And the same trick will also work here. Yes? But what can I factor out here this time? Yes, just state. Yes.
X squared, y squared.
X squared plus y squared. And then what is left is x plus y. And then it's minus 160. And I think everything is clear now, yes? What is this one? This is my question mark. This one is minus 2. But can you tell me what is this one?
4.
It's positive 4, yes? Because I have it on the board. X squared, y squared is xy to the 2. So it is minus 2 to the 2, which is 4. So this is 4. So it becomes minus 8 is minus 160. And then the question mark is minus 160, positive 8, it's 152. So that's the answer. Okay, another strategy you wanted to talk about, and then we will finish. So what's the other strategy? Who wanted to talk about? Yes, you?
You could also use x plus y times.
Yes, because my goal is to make x5, y5. That's one possibility. Another possibility is this one, yes? X plus y is given to be minus 2 from the beginning. And I found x4 plus y4. What was the number? Do you remember?
56.
56 or negative? Yeah, positive. Positive 56. And then I multiply them again. So it becomes xy times x to the 4 plus y to the 4. It's minus what? 112. Yes? And then if I multiply it back, it becomes x to the 5 plus x y to the 4 plus y x to the 4 plus y to the 5. It's minus 112. And then I need this one again, so I put them in the brackets. And this time, what can I factor out? I can factor only xy out. And what is left is x cubed plus y cubed is minus 112. This is my question mark. So what is xy? Xy is minus 2. And I did that one. What was the answer?
Minus 20.
What?
Minus 20.
Minus 20. So it's minus 2 times minus 20 is positive
40.
40, and it's equal to minus 112. I move it to the left-hand side. What would be the answer? Minus 112 minus 40 is again?
Minus 152.
Yeah. So that is the interesting thing about mathematics. You see, you got the same answer. So as far as you are following the correct strategy, you are actually consistent and you can do a lot of things. But the point is that you have to find some time to do the exercises. Otherwise, you will forget by the next one. Okay? So I published a set of problems again today. I didn't teach you more, so I will repeat these things in that question. I will try to make them harder because you know that. If I don't teach, making harder questions becomes a little bit harder, okay? Yeah. Anyway, I will try to do my best to solve, but you need to practice. If you don't practice, it doesn't work that much. Any questions? Okay, good luck, thank you.